by considering integration as the reverse of differentiation shows that integral of secant is equal to a given expression. Hence, using integration by parts shows that integral of secant cubed is equal to a given expression. To show that integral of secant is equal to a given expression, we need just find derivative of the right hand side and show that it is equal to secant x. So derivative of ln secant x plus tangent x plus constant over dx is equal to derivative of ln plus derivative over constant, which is equal to 0. So we need just derivative of ln, and we can see that there is no power, but there is more complicated argument, and we should use chain rule. And chain rule says that we should consider derivative of ln, it is equal to 1 over x, but we should keep this complicated argument instead of x and multiplied by argument derivative. So derivative of ln becomes 1 over argument multiplied by argument derivative. So 1 over secant x plus tangent x, secant x plus tangent x derivative. Secant derivative is secant tangent, tangent derivative is secant squared. It is given in data booklet, so it becomes secant x tangent plus secant squared x over secant x plus tangent x. And we need just simplify it to get that it is equal to secant. There may be a few ways how to simplify it. I just write secant as 1 over cosine and tangent as sine over cosine, and get that it is equal to sine over cosine squared plus 1 over cosine squared, 1 over cosine plus sine over cosine, and multiply each term by cosine squared and get sine x plus 1 cosine plus sine times cosine. We can see that there is common factor cosine in denominator. We can factor out cosine and get in denominator that it is cosine 1 plus sine and sine x plus 1 in numerator, and we can see that it is equal to 1 over cosine, which is secant x as required. The next question, find integral of secant cubed, and according to the method of integration by parts, we should consider function under the integral as product of two functions, and one function should be considered as u and another as v primed. Then we find u primed v, and integral becomes uv minus integral u primed v. So if we consider secant cubed directly, so we can consider it as 1 times secant cubed. So if we choose v primed to be 1 and u secant cubed, definitely we can find a derivative of secant cubed, and integral of 1 is x, but it becomes very complicated, and it will be very difficult to find this integral. If we choose v prime to be equal to secant cubed, u to be equal to 1, we actually get that integral secant cubed is equal to integral of secant cubed. So it's not helpful, but we can consider secant cubed as secant multiplied by secant squared. So integral secant cubed x dx is equal to integral of secant x secant squared x secant squared x dx, and again we need u v primed v, and if we choose v primed to be equal to just secant, integral is ln, and u to be equal to secant squared. Definitely we can find derivative, but again it becomes very complicated and it will be difficult to find integral. But we can consider u to be equal to secant x and v prime to be equal to secant squared x. Hence u primed is secant tangent, formula is given in data booklet, and v is tangent, formula again it is equal in data booklet. Then it is equal to uv secant tangent minus integral u primed v secant x tangent multiplied by tangent, so tangent squared x dx. And there is formula for tangent squared in data booklet, and it says that tangent squared it's secant squared minus 1, so we can use it and get that it is equal to, because it will be difficult to find this integral directly, so it is equal to secant tangent minus integral secant x secant squared x minus 1 dx, and if we open parentheses here we get that it is equal to secant x tangent x minus integral secant cubed x dx plus integral secant x dx. And we can see that integral is secant cubed, and also there is secant cubed here, so we can move it to the left and get that 2 times integral secant cubed x dx is equal to secant x tangent and plus and integral over secant x, it's this ln, so plus ln secant x plus tangent x and plus constant, and just divide each term by 2 to get integral secant cubed x dx is equal to 1 over 2 secant x tangent x plus ln secant x plus tangent x plus constant over 2, it's another constant, let it be again c or c1, it doesn't matter, and hence we get expression as required. And that's all for this question.